So welcome to a new lecture on stiffness matrix method of analysis. Today we are going to derive the global stiffness matrix for a beam element. So the beam element basically consists of four system coordinates. That is called as global stiffness matrix that we are going to derive may be represented by symbol Kg as well. Okay. In the previous problem, we discussed about stiffness matrix for a beam element considering only two system coordinates, that is two rotational coordinates. Here, I am interested in considering four system coordinates. System coordinate 1 is in translation, that is displacement in x direction or y direction, that is translation. And second system coordinate is a rotation. Third is again translation, fourth is rotation. So how will I derive? The first case is I apply first unit displacement in the first system coordinate or first coordinate direction. First coordinate direction is basically a motion in y direction. So it can be a displacement in the y direction. That means the AB beam has displaced to the position A dash. It has moved to the position A dash, producing a displacement delta equal to 1. Okay, so what happens? This is a case of sinking of support. This is the case of sinking of support. So due to sinking of support, instead of the position A, it has changed to A dash. So in order to overcome this sinking, the structure itself will try to come back to its original position by inducing a moment inside it. That moment value is given by the formula 6EI delta by L square, where delta is equal to displacement. Here it is 1, hence delta is equal to 1. Hence, I will get the value as the moment value as 6 EI by L square in anti-clockwise direction. Again, one more 6 EI by L square is produced in the joint B in the same direction as that produced in A. So together adding these two moment values, I will get 12 EI by L square as a resultant moment acting in anti-clockwise direction, which is shown here. So this is a total moment acting at the beam in order to overcome the sinking of support. That is 12 EI by L square is a moment. So this moment is induced in the structure, right? So the structure also need to overcome this moment, that is overcome by the support reactions or the support reactions at A and B. RA and RB will cancel out the 12 EI by L square moment so that equilibrium is maintained. So how will it cancel out? RA and RB are support reaction, that is forces. So how will I cancel out a moment? Force into, so for which force into perpendicular length will give me moment value. So 12 EI by L cube may be the support reaction value. That into the perpendicular length, that is length of the beam, will give 12 EI by L square moment. So this is a couple actually. That is length L, 12 EI by L cube, 12 EI by L cube. It's a couple or a moment. It will produce a clockwise moment of 12 EI by L square, which will oppose this moment. Okay, it will oppose the 12 EI by L square moment and cancel out, and the equilibrium is reached. So my idea is to find the moment values at the support A and support B, as well as the reaction values at the joint A and joint B. Okay, let's see. See this figure. The K11 term represents force at the first position due to load at first unit displacement at first position, right? That is K11 is force at 1 due to unit displacement at 1, right? Second one is this one and the first one is this, that is a location. Here the first one is the location of the first system coordinate. First system coordinate is a translation. So we consider a delta value or a support reaction. This one will become support reaction RA will become my force value. So my answer is 12 EI by L cube. This is my K11 and K21 second system coordinate, that is rotation coordinate. Rotation coordinate. So I have to consider the value of the force produced in the moment direction. That is a rotation value 6 EI by L square. It is acting anti-clockwise, which is opposite to that of the system coordinate 2. System coordinate 2 is in clockwise direction, but the moment induced or moment produced in the structure is 6 EI by L square, which is acting anti-clockwise. So I gave a negative sign here, K21. Now K31. Third position is this one, right? Third position is this one. It is a translation. So translation is induced by whom? By a support reaction RB. And see RB value. RB is acting downwards, which is opposite to that of system coordinate 3. So I use a negative sign again and write the value of 12 EI by L cube because stiffness is nothing but force value produced due to unit displacement. Here the unit displacement is this one, delta equal to 1. By applying delta equal to 1, I get all these four values, that is 12 EI by L cube, 6 EI by L square, 12 EI by L cube, and 6 EI by L square at four different positions. What are the four different positions? First position is here, second position 2, third position, and fourth position. Now K41. Force at 4 due to unit displacement at 1. Fourth position is rotation, that is fourth system coordinate, that is this one, moment value. It is given as 6 ci by L square. So this is from positive or negative, it is anti-clockwise, but fourth system coordinate is clockwise. So a minus sign is also given. So minus 6 ci by L square. So we got four terms. Next is apply unit rotation, that is second system coordinate. Unit rotation at second coordinate. So I am interested in applying system second system coordinate as a rotation. A rotation is produced theta equal to 1. So I have to give displacement as theta equal to 1, that is rotation equal to 1, and find the values. So due to a rotation produced at this end, a moment is induced. The value of that moment is 4 EI theta by L square. 4 EI theta by L. So theta value is 1 because unit rotation. So the moment value becomes 4 EI by L. And half of this moment is transferred to the opposite end by carryover factor. So here we will produce a 12 EI by L at the second position. Now, in order to resultantly, how many moments are there? Here there is 4, here there is 2. Adding up that, I will get 6. So 6 EI by L moment is induced in the structure. In order to overcome this one, the support reaction will produce 6 EI by L square force. So 6 EI by L square into length will give me 6 EI by L. Okay. So writing the terms, K12 means what? At the first position due to unit displacement or unit rotation at second system coordinate. Second system coordinate is a rotation coordinate. So I applied a moment or a unit rotation. I applied unit rotation. I applied unit rotation at the 2 at the 2 and calculated K12, K22, K32 and K42. So K12 is due to direction of first system coordinate, that is this one, right? That is translation. 6 ci by L square acting downward, but my first system coordinate is acting upward, hence a minus sign, then 6 ci by L square. K22 clockwise direction, moment value 4 ei by L, positive value. K32 again translation, that is acting, this one is acting upwards, that is same as in the direction of the third system coordinate, hence positive value 6 ei by L square. And K42 is 2 ei by L, clockwise positive value. Okay. Then apply unit displacement at a third coordinate, that is what? Translation. So what happens? The system again sink by delta equal to 1. As a result, in order to overcome this one, 6ci by L square is produced at end B as well as at end A. Resultantly, adding up 6ci by L square and 6ci by L square, a resultant of 12ei by L square is acting in the structure. So in order to overcome that resultant moment, the support reactions will produce 12ei by L cube. Together will produce a moment that is 12ei by L cube into L will result in 12ei by L square, which will resist the 12ei by L square moment. So from which we will again find K13, K23, K33 and K44. Not K44, it is K43, K43. Okay, yes, same as in the case 1. And again case 4, same as in the case 2, apply unit displacement at the fourth system coordinate in clockwise direction. It will produce a theta equal to 1, that is unit rotation. Find the 4 values, that is K14, K24, K34 and K44. And finally, adding up all these values, I will get a 4 by 4 matrix as written here. So the simplest method to remember this one is just study the sign conversion. It starts with a plus, then all three negatives, then minus, 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 then all the rest of these are all positives. So you can code it in this way so that you don't forget it. Here also checking 12 ei by L cube, 12 ei by L cube. Here 6 ei by L square, 6 ei by L square. This repeats here 12 ei by L cube, 12 ei by L cube. 6ei by L square, 6ei by L square. The difference is that here it is 4, here it is 2. Here it is 2, here it is 4. In this way, you can study 4 by 4 matrix. You have to by heart this value for doing direct stiffness method. Sometimes a 3-mark question to derive this stiffness matrix may also be asked, so which you have to draw the figure for thinking of support and then calculate the values and finally add it up to get the matrix.